Hi. Thanks so much for coming in. I think it's about time, right? So we're going to start off right now. And this is a fairly sort of small, intimate session, so please feel free to just raise your hands and ask me questions through the presentation. I think we have the time to be interactive, so I like to offer that option to people. And one of the other things I also want to do, because this is sort of a multidisciplinary conference, is try to figure out what the room is. Raise your hands if you primarily identify or primarily do front-end work. Okay, about like 60–70% of the room. And then raise your hand if you do primarily back-end work, if you classify yourself that. Oh, actually, whoa, okay. So a lot of full stackers who are raising their hands for both. Okay, so I know how to sort of, I guess, pitch that and communicate about that. And this is a little bit front-endy, a little bit full stack architecture, a kind of a talk. And so if you find yourself struggling to place where this is about, that's actually why we're here. We're talking about the transitioning of stacks and how stacks are moving towards the front. And the primary overall question that I want to start people off with is, how do you distribute your software? I think this is something that we don't really think about because we're primarily concerned at this conference and in our jobs about writing code, about maintaining code, about deploying code. And I think a lot of us, like when we're in the mobile world, which it's a lot of it's quite a different world from the web dev world. We develop in Xcode, we build to IPA artifacts, and then we deploy to the iOS App Store. And Android, same thing, Android Studio to APKs, and deploy to Android. And what do we do for the web? It's kind of a little bit up in the air, right? We're not really sure, and things are kind of in flux, and there are all of these cool tools from different cloud providers, and you're like, I don't know, all of them sound really cool. So this is the question we're going to explore today: distribution of your web software to all these browsers, and what goes in between. So my name is Shawn. I go by Swix on the internet. I'm a big proponent of learning in public. I think it's the absolute best way to sort of accelerate your career. That's why I'm here. That's why I think is beneficial for everybody to practice. I'm also a moderator of the r/React.js subreddit, where there's 150,000 of us talking about React, hiring each other, discussing best practices in React, and you're welcome to join us. And I also work at Netlify, and this is not a Netlify-specific talk, but Netlify is a huge proponent of the JAMStack as a better architecture, and we'll talk about the reasons why that might be. So let's talk about the JAMStack. Basic definition: what is the JAM? That stands for JavaScript APIs and Markup, and we'll explore why this is anything interesting at all, because I think for the people who've sort of been around for a while, isn't this a fancy word for static sites? Come on, like how can we do a 40-minute presentation on this? And it is true in one sense, but things have changed in the past 20 years of web development that make this a totally different proposition from what it used to be. That's why we're here. And in fact, if you're a developer of any sort of tenure at all, you're already glazed over with all the stacks, right? I mean, I just went on the Wikipedia page for stacks, and I just pulled all these names, and I'm sure you can name even more. I was just at Tracy Lee and Robosel's presentation on the PAM stack, which is more about process and mentoring, and it's not so much about specific technologies. I'm gonna put this all in context so that you can actually understand the history that we come from. So in the beginning, when we made the very first web page, it was actually that easy, right? Like we put something on it. We put raw HTML code on a server, and that's the very first CERN web page, and that was it. You hit a server, you requested that data, and it came back, served back that request, and you displayed it on a browser. And I think obviously that scales pretty well, and then it all started to go wrong from there, because the first thing we wanted to do was to start making things that were dynamic, right? So we used to code with like as simple as a notepad, code directly to HTML and send it to browsers. Now we actually have to run a program behind it. So for example, in this countdown page, to run the countdown, you have a running program that checks the time and generates the page on request, and then outputs that HTML. And the only way to refresh that countdown was to literally refresh the page. Obviously, once you have some running logic, you also want some layer of persistence, and that's something that gets you closer to the modern day version of anything sort of cruddy, which the typical profile is something like a WordPress, where you have a database backing behind some kind of logic behind a server, which generates that request every single time someone visits your site. And that actually pretty much tells the story of the 1990s to 2000s. It was actually a lot of fighting in between. I'm glossing over so much detail because there was this whole debate over what kind of stack actually would win out. And the most successful ones, it ended up being the open source stacks, but it definitely didn't look like that was the case for much of that period. But that is what became prevalent and dominant, which is the Lambda stack. And so that model of simple delivery from just writing that page and then delivering it directly to the browser became a little bit more indirect. We started to have these separate machines from what we code on, and those are boxes that we are running the Lambda stack with, and then we have this request cycle, right, from browsers to the server, generating HTML and sending it out to the browsers again, and just back and forth. And that's fine. That's cool. There's some problems with that, though. And we started to feel that as we sort of scaled and the internet exploded and took over the world. So the first problem to sort of think about is the need for caching layers. So load balancing on one side of, I just put in representative boxes. Obviously there are different names for different kind of things, and depending on your use cases, you're going to have different technologies that suit these things. But some sort of load balancing, some sort of static caching in between all these servers, so that you're reducing your load, and just like when you hit the physical machines in one box, you need to go fill over horizontally to another, and so that adds an extra layer of complexity. And the core insight here. Oh, and then we added one more core piece of technology that sort of sidesteps all this, and I just put that in there as a CDN layer. And the core insight here is that traditional stacks, you add extra layers of infrastructure and add extra layers of static layers because your fundamental assumption is still that you have a running box somewhere that generates your page on request. And I think that's the core assumption that we're trying to tackle today. So the problems with some of these, this is the standard list that we sort of go with, and I'm sure you can come up with your own list of issues. Auto scaling, and some of these have been actually solved by some of the platform providers, right? Like if you don't want to think about it, you can pay AWS or Heroku to do auto scaling for you. Release engineering, they're dedicated services that have individually come up to solve each of these problems. But the only reason we have all these problems in the first place is because we still have this core assumption of a running server. And the fun way to put this is we just put it like kind of slightly askew on a deck, and it all looks like chaotic, and we call this accidental complexity. Like when we wanted to deliver our pages to the user, this is all the crap that we have to go through to just make sure things stay up and things get delivered at a highly available manner. Is there a better way? We'll see. Well, I'm just going to collapse all of them into sort of 3 mega factors, and it's primarily to do with security because you have a large surface area, injection attacks, all that. Reliability, and that's also including the availability of your overall system, as well as complexity / cost. I kind of put this together because you can always pay more to have someone else deal with the complexity for you, or you can just hand roll it yourself and deal with that complexity yourself. And so there is one parallel trend over these past 20 years that also was an interesting but kind of toy concept, which is separating that concept from the data generated model, generating to static pages, and then only serving those static pages from a from an edge server. And so this is kind of a toy. No one really took it seriously. And sometimes you don't take it seriously to the point of not having a logo. And that's Yggdrasil, one of the earlier static site generators. And so I kind of call these generation 1 SSGs, because the only thing they do is output HTML from data. And they use sort of increasingly available technology. So for example, Bloxam over here was written in PHP. I think, and then the little bit more modern ones, I chose examples of Jekyll, which was invented by Tom Preston Warner at GitHub. Hugo, written with Go, also a newer language, and Middleman with JS. And so all these are fine, and those are simpler ways of sort of dealing with it, but not really serious for anything else other than sort of blogs and marketing sites. So then we come to the next phase of stacks, right? We had the JAMStack, and that was fairly successful. And obviously, like, JS developers start to get in there. And now we started talking about the mean stack. And the whole sequence of this is that JavaScript got serious over the exact same time. We standardized the language in 1997, and then we got very excited in 1998. We had the next version. 1999, we had ES3, and then 10 years happened that we don't talk about. And then, finally we achieved some harmony in 2009 and 2015. And now we have an established annual cadence of JavaScript releases. And it feels like a lot more of an established language that you can do serious engineering of apps in. So, OK, all right, we have some frameworks coming up on the front end, right? We've got Ember, Knockout, Backbone, Angular. And then we looked at the back end, and we were like, yeah, I mean, it looks like we can do all that in JS, and yeah, I mean, we have the rough equivalents of all these technologies on the back end as well, and that is the dawn of the full stack JavaScript craze, right? So this is and one particular flavor of full stack JavaScript is the mean stack, right? And this is coined by Val Karpov, actually only 6 years ago in 2013. And a lot of people actually identify themselves as mean stack developers today. And then you notice that we used to have, JAMStack used to describe all the server-side technologies and no front end. And now the mean stack has 2 things on the back end and 2 things on the front end, right? Angular is front end, but I guess Express is kind of like still back-endy. But you can see that things are slightly moving over. Like, you're no longer concerning yourself with the operating system. OK, so let's keep going. The other thing that starts to come up with all these sort of front-end frameworks is the phenomenon of client-side rendering and routing. So whatever you're doing, you're writing code to the mean stack. You're deploying those. You're sending over those HTML5 and JS5, I guess. I don't know what this logo is about. But then you're sending it to the browser, and then instead of getting a full refresh of the page, for faster speed and also better user experience, you're just sending from JS incremental requests for data and then re-rendering on the client side. And that is a slight improvement. You probably saw this first in your lives in Gmail, right? And now it's taking over most of the way that we deliver front-end web applications. So, OK, we've rewritten everything in JavaScript. So we haven't really solved anything, and we actually added a new problem, and that is performance. And so let's talk a little bit about that. One of the main, if you're in JavaScript Twitter at all, one of the main debates that always pops up is the web performance of apps. In a real-world sort of sense of performance budgets, if you do the math and you want to have some assumption of, like, you want to have a limit of 5 seconds time to interactive. You want to have some assumption of 400 kbps link, 400 millisecond round trip time, blah, 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 carry the 1. You actually work out to about 130, 170 kilobytes of critical path resources as a budget for initial load. And so if you do the math, that's the maximum region that you're allowed to deliver before your page starts to be unusable in terms of how slow it takes to load. Unfortunately, we actually kind of exceeded that around about in 2011, and now we're standing at about 400K for the median page, and a lot of pages bust that very easily. So, the other thing is also about the performance in terms of what we lose when we move to single-page apps. So this is the default output of Create React App. A lot of metadata over here, but in fact, the only piece of content is this empty div ID equals root, and then a close div. And that's all you're given in a standard Create React App. And obviously, so when you load a page, you're just going to get a blank page until the rest of JavaScript comes in, and then you load and you parse and run that JavaScript, and then you see something on the screen. So that actually takes a long time. You have that HTTP fetch. Then you fetch that JS bundle, and then you render the app, and then you're interactive, right? So there's quite a lot of blocking considerations going on here as we sort of move our applications from server-side generated pages to front-end apps. So we have all the same problems as JAMStack: security, reliability, complexity, cost, and we added extra performance concerns. Not exactly clear that it's better, but more people can write it because JavaScript is more accessible. Fantastic. I think the mental model that we started to realize was wrong was we were doing this. We're doing a request of HTML. Then we're requesting from the HTML, requesting all the assets. Then we're decompressing, parsing, and rendering the JS, and then we're rendering. So the main trick that we realized to get around this was fantastic, and this is my most proud visual on this talk, which is we flip the order. And so now we can first request the HTML with inlining styles, inlining SVGs, and immediately show something on the screen, right? We don't have to parse and decompress JS anymore. So we have something on the screen, and then we lazy load all the other stuff and hydrate them as we come along. And that's what the sort of newer generation of frameworks all let you do, together with tooling like Webpack. And this is all fantastic, and it takes a whole bunch of engineering, and that's why front-end engineering as a sort of discipline actually gets more and more challenging over time. So with that trick, we call it server-side rendering. We've actually been able to diminish TTI quite a bit, and that's fantastic, right? That seems like a little bit of progress, given this assumption that you're still doing something like a JAMStack. But you're still viewing the world as like two very binary options. You have full client-side rendering. You have full client-side rendering, and then you have full server-side rendering, and nothing in between. And it seems like the two very sort of binary options. And in terms of stack choice, it doesn't give you a lot of flexibility in terms of like what else you could possibly do. So we'll explore this. I actually blanked out the middle parts. So that's all happening in terms of stacks. And then the environment around the way that we do web development is also changing dramatically as well. So the first thing is Git 1, right? Like right now, we can't imagine working without Git. But for a long time, we're still FTPing servers, we're playing row subversion, and whatever else came before that. I wasn't even around for that. but you get the idea that I think now the norm that version control is a thing. You pass the Joel test on the first go. You're doing CI/CD. This is established as good practice. Like it's not. I don't even explain it. It's a given. That's the first trend. At Netlify, we take it a little bit further. We do immutable deploys. We do deploy previews. So like before when you make a PR, we already build and deploy that preview, so you can preview that page before you merge it in a production-like settings. And we even do split testing, like A/B testing of different branches based on your deployment. And all this can be based on Git. Just that's the only API that you have to learn, which is fantastic to me. Second trend, there's 5. Second trend is the API economy. So these are the rise of companies that are dedicated only to serve other developers. Previously, you had to own the entire stack yourself. Now you portion it out. You portion stuff out that you're not specialized in to dedicated service providers. I do not ever want to do anything to do with banking, right? I'd rather get Plaid to do it for me. Like that will connect to all the banking services in the US for me. I don't ever want to manage my own communication like SMS infrastructure, so I'll use Twilio for that. I'd rather hire the world's best experts in these individual things because that's not my main goal. I'd rather outsource that and focus on my core business value. All right, API economy, fantastic. In fact, there's even more providers. Like just apart from just the APIs, there's all these other things, and people actually, and VCs have actually been collecting all these in JAMStack landscape charts. This is one from CRV, and this is another one from Redpoint, just to give you an idea of like who are the players in each of these fields. Definitely feel free to take a photo, but I'll also put this up on my own site later on. You can check and think about like what are the opportunities. The two main opportunities which people are sort of crowding towards are it's kind of in these two fields of the headless CMS, where there's been a lot of fundraising going on. The utility APIs, where we already talked about the API economy, and there are quite a few unicorns in there. And now they're starting to invest in a little bit more in the front of the stack. So Gatsby, in particular, being a particular sort of high-profile open source project that also raised a decent amount of funding. And I also make a special shout out to indie hackers, so people who are working on side projects and just kind of by themselves and not venture funded, because I think that's a strong use case for the JAMStack as well. Go check out this article that I wrote on the indie hackers page if you're interested in that kind of thing. So the third trend that's going on is the serverless trend. Obviously, in 2014, Amazon launched AWS Lambda, and then it was quickly copied by Microsoft and Google. And I think at this point in time, I won't bother explaining serverless to you, but I think it's been proven out that it's relied on at scale, trillions of requests a day by some of the biggest production environments you can work with. That's interesting because now you don't have to manage your own servers. So you can see that the typical use case for servers are being chipped away. Like you no longer have to run a lot of your own logic. You can hire it out to dedicated APIs, and even for your own logic, you can run it on serverless platforms. That's very interesting. The other thing that's also going on, the fourth trend, is build tools, right? So we have all these things that are helping us engineer things really well. I always like to do a fun quiz. Obviously, this is TypeScript and Flow, and you probably recognize NPM. You probably recognize Yarn. Just a quick quiz. Does anyone know what that thing on the left is? This is sort of like a trivia quiz. Anyone? No? Yeah. Google Closure Compiler. So when people sort of bundle their JavaScript, they want to optimize it a little bit more. Typically, you think about Parcel, Webpack, and Rollup, but GCC is actually really good for libraries. All right, and then the fifth and final trend is static site generators. Here's the founder of Netlify, Matt Billman, talking about it in Smashing Magazine. This was their top article, surprisingly, in 2015. In the entire year, and it's so interesting to me because it was calling out this thing. So Netlify used to be just a sort of CDN layer, and it just used to host static sites, and it just used to track static site generators as part of like its extra value-added service. And they started noticing all these rising GitHub stars, all this renewed activity in static site generators, and they started to call it out. And I think, and here's the site staticgen.org, and you can actually see like the trends over time in GitHub stars and who's sort of on top in terms of projects. And it's very interesting because it seems like it's growing rapidly, and with all this available options in programming, it's not necessarily obvious that that the interest in static site generators is so high. And I think it's because like people wanted something simpler in terms of their deployment options. There's also a new generation of static site generators, and these are all enabled by JavaScript. So what that gives you, apart from the first generation of generators, is templating, components, sort of integrated styling options, as well as rehydration into some combination of server-side rendered project at first, and then hydrating into single-page apps, so you have a fully dynamic site. Some of these projects, like Gatsby, call themselves, in fact, they don't call themselves static site generators anymore. They call themselves PWA generators. Like you're generating all the assets that you need for a progressive web app, and when you hit any of the pages that have been generated, you hydrate into a fully sort of dynamic web app on the front end. So these are some of the projects. I'm actually working on one based on Sapper, but they're all enabled by JavaScript, and that's a lot more interesting. So The argument for static site generators, of course, is that instead of doing work on request, you're doing work ahead of time at build time, and so that you're at the very maximum limit of what the speed should be for time to interactive, because literally you're requesting for static files from the edge nodes in your CDN. You don't have to hit any origin. And you don't have to cache anything because, so there's no cache invalidation issues. You're literally, that's the maximum limit in terms of speed. And so putting them on a chart, you can kind of get some kind of justification. CSS Tricks actually recently, I think like two days ago, put out a analysis of, let's put some hard numbers behind what the speed up is from sort of traditional server-side rendering to JAMStack, and the numbers are fairly significant. I don't have them here though, but highly recommend talking about them. And with the full range of JavaScript options, you also then have a full range of hydration options. So this is the full chart from Google talking about rendering on the web, and you have this spectrum between full server-side rendering and full client-side rendering, and this sort of options in between, this menu of options in between. Again, I don't have time to talk about every single detail, but I think as much as you need for SEO, as much as you need for high performance, and if it doesn't require sort of highly, authenticated data, right? Like if the data, if what you show on screen changes for every single user, then there's no point pre-rendering it. Just render an empty shell for that page, for that part of your screen, and then use JS to ping APIs. And that is arguably lighter, faster, and it's more responsive for your users as well. And we can talk about that. There are a lot of people who have individual, context-specific questions about this, and I can help you work through it. So take all these trends. Again, these are all the environment. It's like a meta environment around programming, right? This is not strictly programming, but it kind of like is the trends that are sort of supporting it. You have Git workflow, build tools, serverless, API economy, and static sites sort of renaissance. What do you get when you sort of put all these things together? And that's the context at which we arrive for the JAMStack, right? It's a modern architecture for creating fast and secure sites and dynamic apps with JavaScript APIs and pre-rendered markup, served without web servers. And that's the most important thing, and that's why there's kind of like an underscore and highlight underneath that. And obviously, when we talk about served without web servers, obviously there's servers there. It's just not yours. So it's the same thing. It's the same thing as sort of wireless cell phones. Like obviously they're wireless. In fact, CSS Tricks, the founder of CSS Tricks, Chris Coyier, actually talks about like JAMStack is kind of focusing on the assets that are being built and delivered, like JavaScript APIs and markup. And he actually realized that the core of all of it is static hosting, and that's why he calls the JAMStack. It's very cheeky so static hosting stack. And his core insight is that everything can be CDN hosted. And that's the real core of it. Like you don't have to use JavaScript, you don't have to use APIs, but you can if you want to. The main thing though is that everything is served from a CDN. And that's why we try to like make it very clear. It's not and. That's why we put a slash through the end. So you don't have to use all three. The main thing is that you're capable of being served directly from CDN. So arguably that is the best theoretical limit of performance, right? And so then you use, for anything dynamic, you use static site generators or data driven, right? So the top field is the first generation of static sites, and these are all they only generate HTML, so you can generate them from data. And then the second tier are all the next generation static site generators, which you can generate from data, but then also once they've delivered their assets to the client, they can also ping APIs for anything dynamic, including authenticated experiences and high frequency update experiences as well. For example, one of our top users at Netlify is a sports betting site with live updating sports bets, and that's a very interesting use case for static sites, because you think that you need some dynamic behavior. Anyway, so there are hundreds more. I have a link on a presentation for some reason. I wasn't really thinking it through when I did this, but that's just a link to stackgen.com, and that actually gives you a really buffet of options that people are making. So yeah, you don't have to use Netlify, because I work at Netlify, so I want to make sure the very clear distinction between my company's interests and just like the overall architecture that is more interesting to the general audience. So you can use GitHub Pages. The GitHub Pages is arguably the original progenitor of the JAMStack concept. But you can host it on an S3 bucket. You can host it on a Raspberry Pi. I don't care. The whole idea is that it's simple enough and portable, by the way, so you're not locked in, because the only thing that you're using is building to a static folder, right? So anyone can serve that. So that's very good for vendor lock-in. And yeah, so Netlify is only one of many options, and there will be more on this page as time goes on. Who uses it? The React Docs, Vue Docs, Sequoia Capital uses it for like 15,000 pages. Smashing magazine for all their articles. I like to highlight the corporate users: Citrix, Trinet, PayPal, and particularly PayPal. I like to talk about them. We'll come back to them. But also Netlify.com. This is the dynamic app that users use. People are always surprised to learn that Netlify.com is hosted on Netlify. And I mean, it's kind of self-evident, but for such a dynamic, authenticated behavior thing, a lot of people are really surprised that you can build this kind of experience with just a static site. And that's also fantastic as well. I like to talk about the PayPal case a little bit. So this is a talk done by Jaman Ferguson at PayPal, done at InfoQ London, on bringing JAMStack to the enterprise, because they don't use Netlify. They actually evaluated Netlify as a vendor, and they were really interested in the stack, but they actually couldn't use us because of the financial certifications that they needed us to have, and we didn't have it at the time. We since have got that SOC 2 certification. But they moved PayPal.me onto a JAMStack architecture, and they built all that infrastructure internally just to achieve this. And I think this is a fantastic talk for JAMStack and the enterprise, financial concerns, so high security risks, and at large scale on the scale of PayPal. So I highly recommend checking out that talk as well. Let's talk a little bit about developer experience. I think a lot of people put this front and center. I think it's a nice to have, even though I work as a developer experience engineer. And I think the model for this is very simple. Like, you have local builds, right? You build locally, and you're developing and testing. And once you're ready to deploy, you commit to Git. And then you're just building this on the same sort of in the same model, and you're just deploying to CDN, right? This is a very intuitive model, because you can replicate anything in production on your local device. And that's actually something I worked on primarily this year, which is replicating production environments on your local desktop, so you can test it with a very strong one-to-one benefit. That's called Netlify Dev. I don't have time to explain all of it, but it's a very, very fascinating developer experience, because you get very fast iteration just building locally. All right, here's the only Netlify specific sort of slide in the whole deck. At Netlify, we take the JAMStack, and Netlify sort of lives and breathes and dies by serving the JAMStack developer. And we assume that, like, given the sole assumption that you're working with the JAMStack and you're building JAMStack sites, what can we do with that, and what services can we build on top of that? And it turns out you can do a lot. And so you can do deploy previews, branch functions. You can actually add serverless functions alongside of your front end code, and deploy them atomically from front end and back end. So in theory, you never break, because you can just roll back and forward. We add static forms as well, and then all this other stuff, all this other sort of value-added stuff. I do want to highlight analytics, which was probably the most successful launch of Netlify this year, and that is basically server-side analytics which are unblockable, because you're not including a bit of JS on the front end, right? Like you're just reading CDN serving logs, and aggregating it in a non-identifiable way, which is GDPR compliant, which is fantastic, especially here. So yeah, that's the whole journey to the JAMStack, right? Like, and I think it's behooves us to really ask, like, why we're talking about this, and it's really about the changing platform in terms of computing. Mobile has obviously taken over in terms of the primary platform that everybody uses, particularly to visit websites. But even on the time, in terms of time spent that we're on mobile, the web is actually in a bit of a challenge, right? Like most of the time that we spend are actually in apps and not browsers, and that's a problem for the open web because a lot of these programs are behind either Apple or Google, and that's a big problem for the open web, unless we can start to compete in terms of the way that we deliver software. So. That's sort of where we ended up. We're building and delivering all these programs on native platforms, and we should also be able to build and deliver. And the answer to how we deliver the software is with the JAMStack, is by coding, by sort of building in that sort of nice developer experience chart to static assets and serving static assets from CDNs to all the browsers. Yeah, and that's the introduction to the JAMStack. Thank you very much.